All right, if you want to be a data scientist, we need to talk about the types of data that you might encounter and how to categorize them and how you might treat them differently. So let's dive into the different flavors of data you might encounter. All right, let's talk about different kinds of data that you might encounter. Pretty basic stuff here, but got to start with the simple stuff and we'll work our way up to the more complicated data mining and machine learning things. But it is important to know what kind of data you're dealing with because different techniques might have different nuances depending on what kind of data you're handling. So there's several flavors of data, if you will. And I like ice cream, which is the main reason this slide is up. But moving on, they are numerical, categorical, and ordinal data. And again, there are different variations of techniques that you might use for different types of data. So you always need to keep in mind what kind of data you're dealing with when you're analyzing it. Let's start with numerical. It's probably the most common data type. Basically, it represents some quantifiable thing that you can measure. Some examples I have here: heights of people, page load time, stock prices, things that vary, things that you can measure, things that have, a big range of possibilities. Now, there's basically two kinds of numerical data, so a flavor of a flavor, if you will. There's discrete data, which is integer-based, and for example, that can be counts of some sort of event. Some examples here: how many purchases did a customer make in a year? Well, that can only be discrete values. They bought one thing, or they bought two things, or they bought three things. They couldn't have bought, 2.25 things or 3 3/4 things. It's a discrete value that has an integer restriction to it. The other type of numerical data is continuous data, and this is stuff that has an infinite range of possibilities where you can go into fractions. So, for example, going back to the height of people, there is an infinite number of possible heights for people. You could be 5 feet and 10.37625 inches tall or whatever, or the time it takes to do something like check out on a website could be any huge range of possibilities, 10.7625 seconds for all you know, or how much rain fell in a given day. Again, there's an infinite amount of precision there. So that's an example of continuous data. So to recap, numerical data is something you can measure quantitatively with a number. And it can be either discrete, where it's integer-based, like some sort of event count, or continuous, where there are infinite precision that you can have available to that data. The second type of data that we're going to talk about is categorical data. And this is data that has no inherent numeric meaning. You can't really compare one category to another directly. Things like gender, yes-no questions, race, state of residence, product category, political party. You can assign numbers to these categories, and often you will, but those numbers have no inherent meaning. So for example, I can say that the area of Texas is greater than the area of Florida, but I can't just say Texas is greater than Florida. I mean, they're just categories. There's no real numerical quantifiable meaning to them. It's just ways that we categorize different things. Now, again, I might have some sort of numerical assignation to each state. I mean, I could say that Florida is state number 3 and Texas is state number 4, but there's no real relationship between 3 and 4 there, right? It's just sort of a shorthand to more compactly represent these categories. So again, categorical data does not have any intrinsic numerical meaning. It's just a way that you're choosing to split up a set of data based on categories. And the last category that you tend to hear about with types of data is ordinal data, and it's sort of a mixture of numerical and categorical data. And a common example is star ratings for a movie or music or what have you. So in this case, we have categorical data in that it can be 1 through 5 stars, where 1 might represent poor and 5 might represent excellent, but they do have mathematical meaning. We do know that 5 means it's better than a 1. So this is a case where we have data where the different categories actually have a numerical relationship to each other. So I can say that 1 star is less than 5 stars. I can say that 2 stars is less than 3 stars. I can say that 4 stars is greater than 2 stars in terms of a measure of quality. So it's sort of in the middle there. Now you could also think of this, if you just thought of it as the actual number of stars as discrete numerical data. So definitely a fine line there, and in a lot of cases you can actually treat it that way. So there you have it, the 3 different types. There is numerical, categorical, and ordinal data. Let's see if it's sunk in. Don't worry, I'm not going to make you pass in your work or anything. Quick quiz. So for each of these examples, is the data numerical, categorical, or ordinal? Let's start with how much gas is in your gas tank. What do you think? Well, the right answer is numerical. It's a continuous numerical value there because you can have any infinite range of possibilities of gas in your tank. I mean, yeah, there's probably some upper bound to how much gas you can fit in it, but there is no end to the number of possible values of how much gas you have. It could be 3/4 of a tank, it could be 7/16 of a tank, it could be 1/pi of a tank. I mean, who knows, right? How about if you're rating your overall health on a scale of 1 to 4, where those choices correspond to the categories poor, moderate, good, and excellent? What do you think? Well, that's a good example of ordinal data. It's very much like our movie rating data. And again, depending on how you model that, you could probably treat it as discrete numerical data as well, but technically we're going to call that ordinal data. How about the races of your classmates? What nationality are they? Pretty clear example of categorical data. You can't really say that, you can't compare yellow people to green people, right? They're just yellow and green. Just pick two random races that don't exist. But they are categories that you might want to study and understand the differences between on some other dimension. How about the ages of your classmates here in this class in years? A little bit of a trick question there. If I said it had to be an integer value of years, like 40, 50, or 55 years old, then that would be discrete numerical data. But if I had more precision, like 40 years, 3 months, and 2.67 days, then that would be continuous numerical data. But either way, it's a numerical data type. And finally, money spent in a store. Again, that can be an example of continuous numerical data. So again, this is only important because you might apply different techniques to different types of data. So there might be some concepts where we do one type of implementation for categorical data and a different type of implementation for numerical data, for example. So that's all you need to know about the different types of data. Pretty simple concepts there. You got numeric, categorical, and ordinal data. And numerical data can be continuous or discrete. And there might be different techniques you apply depending on what kind of data you're dealing with. So we'll see that throughout the course going forward. Let's move on.